what we started with. 1. Right. Okay. Let's bring them together. Right.
They're the same.
Are they?
They look the same.
Okay. Now, keep that in mind. In here, instead of, let's say, 0, I will go with 2 in here. Beans, I'm going to change it to 15. And figure, we already established that. Did not, maybe change that to, let's say, 5. Right.
Index out range.
First of all, where is the problem?
The size?
Which is? This one or this one?
I get the beans.
Is the beans?
Beans?
No, class number 2.
Try to.
Oh, it's the class number because I think we have like 3 different details there and you only selected 2, so I think we can be, let's try 3.
Let's try 3. Okay. Do not forget. Let's go ahead. Okay. Run it again? Okay.
The class number should be between 0 to 2.
One
I
second.
guess the problem is with the beans.
The problem is, first of all, is here. For the beans, the problem is here. What does it say? So if I do this one as 1, okay? Same problem. Well, the second I go ahead and change it to 0, it went ahead and print it for me. Now, I'm not done, because remember this? What is that? The picture that I have just taken. Are they the same? Are they the same?
No.
No.
Number
Why?
of beans are different.
The figure in here, I have changed it, but it doesn't matter. But what did I also change? The bean. How much do we actually
Because
go
one
ahead?
has more beans.
Yes, in here, it does actually here it had like 30 bean. In here it is half of it, which is 15. So the second I go ahead and change that back to 30, run it, it just went back to the way it was. So, now with the figure, right now it is 5, but what if I go ahead with a number that is way too much, let's say 500, and run it from there. Will it matter? Not in this case, no. Okay. Now, once that is done, let's go, you know what, I will return it back to, what was the number? Okay. Now, what if I go ahead and get the data, target, run it from there. Okay, data irises, let's say target. Is equal to iris dot target. Now, of course, if I do not actually print the data, nothing is going to run for me, so I will print that first and then the data. So if I go ahead, run it from here, I got the whole array again. Now, with all of this, if you want to know if you are running with the correct data or not, where do you also have the data before? Okay. Is this one, and you know what? Let me just take a picture of it so that we can just compare it. Is it the same data or not? Is it the same?
Well, it's the same.
They are the same. So if they are the same, why did we need to go ahead and do all of that? What does that tell me? Everything that we have done in here, we never change the data, we just display the data. We display the data in different ways. Now another thing, what if we go ahead and, let's say what do we have? Okay, there we go. Here. And run this particular program. What do you see? What does it do? What is it doing here? Here.
How many cluster?
Hmm?
Clustering?
Clustering? What do you think it's doing? In this particular line, if I'm going to that, the C parameter takes an array of colors in this case, which as you can see, there is three particular colors. Let's say green, purple, and yellow. They are 0, 1, and 2 in the iris target. Purple for the setosa, green for the versicolor, and yellow for virginica in there. And then they are just going ahead in two subplot. The size is already set to be 121 or and the second is 122, and then they are just making sure that that target, that data is actually displayed in the plot that we need. Good. Now, not all of it. There is, I do believe, at least one or two more where okay, how do we actually go ahead and train it? Well, you know what, I will just copy it all. And here, the test size is, right now, that we are going to use is 2.25 or 25% of the whole data set. We are not using, if you go ahead and let's say do all of this or have all of those numbers. If each dot is actually one data, is it 150? If you number it, is it 150? Does it all of it count to 150? By 4?
By four.
By 4.
Four fiction.
4 fictions. Okay. So basically we're not taking the whole set. We're only taking a small part of it. Quarter of it. A random set, how are we going to know this? Is it the first set of data, is it the middle, or is it by the end? Usually we need to take it not for beginning, middle, or the end. right? Randomly. That's why a random state of 1 fixes the random seed of the function so that you can get the same results every time you call the function, which is important for now to reproduce the same results consistently. Because, again, how many times are you going to run the data to get the correct answer? If it was done randomly, you should get the same answers every time. But if it was done like only the first set of data, and in that first set of data, let's say, especially if it was some place that was either yes or no or not applicable. If the first section, they all answered no, or most of them answered no, while the end of that section, they have answered most of them as is. What is the answer you are going to get? What is the target you are going to get? Nothing persistent, because it is not randomly selected. That's why, in order for us to do it, we need to go ahead and import the train test split. Once that is done, really?
Because I make it right.
No, it should have actually went ahead. X is
X
not
and Y.
defined.
You need to assign X and Y.
Just X, correct me here. X, because we need X to train it, we need X to test it, and then Y to train, Y to test, and then we made sure that it is actually split. And why not? Okay, this I will just look at it later on why that's not 1. I will just, go ahead and run this one. Okay, that one went through. Let's see with the no. Because X is not right. Great. Unless this one actually goes ahead through, it will not go. Okay, you know what? I will just do it from here. Okay, I can pull up here. Great. I will just scroll down. You already have it, so you should be good to go with this. The second you go ahead, you import it. Most probably here's something to do with this particular importation that is not allowing me. I will just need to check up what happened in there. Once that is done, you are going to have the logistic regression in there added, and you will be getting the array. And as you can see right now with the array that you will be getting, it is like -2 point for each like points that you are going to run with. Once that is done, you are going to predict what is the test for X is, and as you can see for that prediction, it just gave it to me as 0, 1, 2, 0, 2, 2, 2, and it is not like when it began right from the beginning, it was 0, 0, 0, 0, 0, and then 1, 1, 1, 1, 1, and then 2, 2, 2, 2, correct? It was just something that is done in random, and it was predicted. Then for the score, it took actually the X text and the Y test, and then it was printed for the score. And for the accuracy score, you can actually go ahead and print for the Y test and Y predict 2. And as you can see, the number it was given to me is 0.78947368421052 6 and 3. Okay? So basically, as many times as you run this particular same code again and again and again, you are going to see that it is going to give you approximately the same number. I have, since morning until now, I have run it 5 times. 4 out of the 5 it gave me the same number. The only reason in the last way that gave me a different number is that I changed how that set of data is going, or which data set is going to be used. Okay? Once that is done, then I'm just going to go into the train. Now in here we made sure that it is in linear, and as you can see, when we went ahead for it, to actually returns the spaced numbers for over a specific interval for the NP line space, so you are going to see that it is actually two lines that are linears that they are going to get, and the probability for it, again, it is going to print the array for me, and that's it. What is the prediction? What is the prediction probability? You can also go ahead and print those numbers. Good. Questions? All of that is just the basic. Good. How many of you are actually comfortable to start writing some coding? Maybe not today. Next week? Good.
It would be good if you can introduce some documents, the syntax of this function.
Oh, that's okay. That's actually a very good question. Good. I had something prepared for that. It was, again, in here, let's see. Here we go. Here. I will post this on Teams so that you have access to it. It is a comprehensive guide to scikit-learn. How does it actually work? What do you need to do it to go ahead and start with it? So basically, if you go with this, like what is important, how do you actually go ahead with it, all of it is actually explained in there. It took me around like 10 minutes, 15 minutes to read through. It might take you a little bit more time to read through that, but it is actually a good read for you to know. Okay? Any other questions? No? Okay. Next class, we are going to start with a new model that is going to be data attributes and information gain. We are going to start with building decision trees using classification method and move forward from there. So, have a nice rest of the day, everyone, and see you next class. And I'm posting this right now so that